Welcome to this eLearn security video training lesson on XPath. In this video, we will see how to identify and exploit XPath injection. Depending on how the target web application behaves, we have to run a few tests to check if the vulnerability exists. As we will see, the target web application does not return any error message. Therefore, we will have to use blind exploitation techniques to detect if it is vulnerable, and if so, exploit it. Let us start inspecting the application and try to find a possible injection point. This is a very simple web application. It allows users to get some information on different countries. It seems that in the home page, there's nothing interesting, so let us keep investigating and click on the link here. This opens a new page showing some information on the selected country. As we can see in the address bar, it seems that the application accepts a parameter named country ID. This will be the parameter that we're going to use to run our tests. First, let us try to type a character that may break the query. For example, let us type a single quote right after the ID. As we can see, it seems we have broken the query syntax, and the application does not return any result. Knowing that, we can start a few more tests in order to trigger two conditions, a true condition and a false condition. A true condition will be determined by an injection payload, forcing an always true statement, while an always false statement condition will output a different result. Before injecting any payload, let us open a text document and make some guesses about the XPath query that the web app runs. Since we do not know anything about the XML file behind the web application, we can only suppose that the application uses a query similar to one of the following. Of course, these are just some of the many implementations the web app may use. Let us suppose the web application is using the last XPath query in the file to retrieve country's information. As said earlier, we have to find an always true and always false condition. To do this, we can try to use the following payload. The first is an ID that probably does not exist in the document, while A equals A is always true condition. To better understand the whole query, let us replace country ID with a payload. The condition is always true, and then we should get some results in the web application. Let us go back in our browser and try it. Great, it seems it is working. Indeed, the application returns information about Italy, which probably is the first country in the XML document. Let us now try to find the always false condition. To do this, we can simply change the value here and see what happens. It is working. Indeed, the application does not return the country information. Now we know that the application is vulnerable to XPath injection. Our first step is to get more information about the XML document structure. For example, we want to retrieve the root node name of the document. To do this, we are going to use some XPath statements to detect the root element name char by char. By using well-crafted payloads, and thanks to the true and false conditions, we will be able to understand if the character used is correct or not. The idea behind the attack is to obtain a true condition by asking the application if the first character of the root node name is equal to a specific character. If not, we will change the character until we find the right one. Once we find it, we will keep going with the second character and so on until we have the complete name. So, let us go back in the text document and start creating our payload. In order to select the root element, we can use the following string. Since we want to know the name of the root element, we have to tweak the payload by using the name function. This query returns the name of the root element, but we cannot use it since it will simply break the XPath query. We have to create a payload that returns true or false, depending on the information asked. So for example, here we may try to add a condition to test if the root name value is equal to a specific string. As you can imagine, this is similar to a dictionary attack, where we try all the words against the condition. We have to find a different way which is faster and more accurate. To do so, we can use the substring function. We will iterate each character of the root name value, and we will stop the iteration when we find a true condition. Our final payload will be something like this. Here we are asking if the first character of the root node name is equal to A. If it is, it will return true, making our entire query true and displaying the information of the country Italy in the web page. In other words, we will distinguish correct characters depending on the page results. Now that the payload is complete, let us try it against the web application. As we can see, we have the same result obtained with the false condition obtained before. So we can say that the root node name does not start with an A. Let's continue and change the A with a B. Here again, we have a false condition. Let us keep going until we have a true condition. Here we are. This time, the application returns the information about Italy. This means that the whole query returns true and that the C character is correct. Note that we know the first character. We need to repeat the same steps for the second character. To do so, we just need to change the value here in order to tell the substring to extract the second character of the name. So, here again, we will start with the first letter of the alphabet, and then we will keep going until we find the correct char. Since it is a very long and tedious task, we are not going to iterate more than this. Instead, once we think we've found the correct name, we can double check it by changing this payload a bit. So let us suppose we think we have the full name of the root element. Let's say it is countries. We can check if it's correct with the following query. This will return true if the name of the root node is countries. Indeed, once we run it, we can see it works. Of course, if the name is not correct, the web app returns the false page, as usual. With this simple technique, we are able to detect the whole structure of the XML document and its content. But as you can imagine, it is a very tedious and time-consuming task. To cope with these issues, we are going to use a very simple tool named xcat. Xcat is a command-line tool that aids in the exploitation of blind XPath injection vulnerabilities. It can be used to retrieve the whole XML document being processed by the vulnerable XPath query, as we all read arbitrary files on the host. We've already installed it on our system, and we can simply run it with the following command. Before running it against the web application, be sure to read the manual at the following address. Here you will find the available options and some useful tips to configure it correctly. Let us now go back into our shell and start writing our command. The first option to set is the HTTP method that the tool has to use. In our case, we're going to use get, so our command will be something like this. Next, we have to specify the target URL, so let's go back in the browser, copy the address, and paste it in the shell. Now we have to set the data to send. In our case, the parameter to send is named country ID, and we can assign a value such as 1. Let us continue by specifying the target vulnerable parameter by simply writing in the command. This may come in handy if we have more parameters to test. The next thing to do is to set the true condition. In other words, we have to specify a string that will appear in the result page if the condition is true. If we go back to our browser, we can see that when a true condition is used, we get information about Italy. So, we can simply use the string Italy to instruct the tool to identify true conditions. The last option we have to set is the command the tool has to run if the query is vulnerable. For our purposes, we want to retrieve the whole XML document and save it locally, so we can inspect it later. To do this, we can use the following options: run retrieve, -- output, followed by the path where to store the results. The command is now complete. We can hit enter and wait a few seconds until it finishes. And the tool has completed its tasks. Let us open the file just created and inspect its content. Here we are. As we can see, the root node name is countries, something that we already knew. Here instead, we have all the other information contained in the document. As you can see, in just a few seconds, the tool is able to retrieve the entire content of the document. This is something that would have been quite impossible to do manually. And this concludes our video lesson on XPath. Thanks very much for joining us.